Greetings, math fans. Alright, so today's topic is called Sum of Infinite Geometric Series. Alright, so here's the deal, math fans. Got a couple of keywords here, so let's kind of highlight things. We got infinite, we've got geometric, and we've got series. Okay, well, you know what everything means, but infinite is you keep going on and on and on. So we're going to use a nice little symbol, infinity. And then geometric, of course, you know is multiplication, right? And then series, you know, so this is multiplication here. We know series is sum, right? So we've learned in the past. Okay, so let's use our nice little friendly formula that we've already come up with. If I said S sub n is equal to a sub 1 minus a sub 1 r to the n power. Don't forget it's just n, not n minus 1, okay? Over 1 minus r. So we've been using this for a couple weeks. And here's the deal now. I'm going to say that n is going to be huge. So we're going to make that, we're going to make n huge. So it's going to be, you know, to the 20th power, to the 50th power, to the 1,000th power, to 10,000, 100,000, million, billion, zillion, gazillion, whatever. Okay? So it's getting really big. And then we're also going to make r over there. We're going to make r between negative 1 and 1. So just for the heck of it, just to kind of teach you guys a little bit simplicity here, let's make r 1/2. Okay? It's between negative 1 and 1. So we'll make r 1/2. So what happens when I take 1/2 and I square it? Well, I get 1/4. Okay, and what happens if I cube it instead? I get, well, 1/8. And what happens to the third power or the fourth power? 1/16, 1/32. So what's happening when I say 1/2 and I make n huge again? What happens if I say 1/2 to the 1,000th power? Okay, what's that going to? What number is it kind of going towards? It's going towards 0. Do you guys agree? Because 1 over 32, 1 over 64, 1 over 128, 1 over 256, right? It's going closer and closer to 0. So here's the deal. This value right here is going to 0. Alright? When n gets big and r is a fraction. Alright? So here's the deal. If that's going to 0, that means this whole thing, 0 times a sub 1, is really going to 0. Okay? So the deal is, when n gets really big and r is a fraction, that whole blue area goes to 0. So really, my new formula, wait for it, it's S sub infinity. So that's, we call that an infinite geometric series, is a sub 1 over 1 minus r. It's actually a pretty sweet formula. So you don't have that a sub 1 r to the end because that's gone, and you just have, basically you just need the first term and you need the ratio. Okay? But here's the deal. So we kind of said a few things here. Again, n goes to infinity. But in order for this to work, this is super critical right here. That r value has to be between negative 1 and 1. It can't be equal to 1. Okay? If it's equal to 1, think about it. If that was equal to 1, this guy right here would be 1 to the whatever power, and 1 to whatever power is still 1. It doesn't go away. It doesn't go to 0. Or if it's a number bigger than 1, so if it's like, you know, 5, right, that obviously it just gets bigger and bigger. It doesn't go away. It's got to be something less than 1. It could be 99 over 100, doesn't matter, but it's got to be less than 1 or greater than negative 1. Because again, if you square negative 1/2, you get 1/4, and then negative 1/8, and positive 1/16. So that's going to go to 0 as well. But it has to be between negative 1 and 1 in order for this to work. Super, super important. Okay. So what I just highlighted here, let's highlight in purple too. Is that going to do it? Oh, look at that, makes it blue. So that is like super important. R's got to be between negative 1 and 1 for this formula to work. Okay. Very, very important. All right. So let's do a couple problems with this now, and see what we get. All right. Cool. So our first problem, I'm just going to give you guys a sequence of numbers. So I'm going to, the directions are going to be find the sum. Okay, and the numbers are 8, 4, 2, 1, ... Now, first of all, how do you know this is an infinite geometric series? Okay, the easiest way to know is right here. Okay, the dot dot dot. If you do not see a dot 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 there, it is I'm going to ask you to find the sum of the first 20 terms. Okay, this dot dot dot. When I say find the sum, and I don't say find the sum of the first 20 terms, just find the sum. And there's that dot dot dot. You know it's an infinite geometric series. All right, so please don't come up to me during the middle of a quiz or a test and go, Mr. Curvis, how many terms do I need to find? Or is this an infinite geometric series? Because what will I say? Go sit down. All right? Okay, cool. So let's just write this formula out here. S sub infinity equals a sub 1 over 1 minus r. So the beauty of this, I just need, first of all, I got to find out what r is. You got to verify the value of r. So in this case, r is equal to 4 over 8, which is 1/2. Perfect. It's between -1 and 1. That is beautiful. All right? And a sub 1 is the easiest thing. You could pretty much have your kid brother help you with this. And if you told your kid brother, hey, could you find out what a sub 1 is? Your kid brother would go, ooh, right here. It's 8. It's the first term. Okay, so that's like super easy. All right, so now let's just plug it into the formula here. So a sub 1 is 8. So S sub infinity is going to be a sub 1, which is 8 over 1 minus 1/2. Super easy. You can put that in your calculator if you want. 1 minus 1/2 is 1/2. 8 divided by 1/2 comes out to be 16. So that's your answer for that problem. That's the sum of all those terms. And some of you guys are like, well, I don't understand. How is that the sum of the terms? Well, let's add a couple of these together. Right? If I say 8 and 4 is 12, plus 2 is 14, plus 1 is 15. The next term will be 1/2, so 15 and 1/2. That next one was 1/4, so 15 and 3/4, 15 and 7/8, 15 and 15/16, 15 and 31/32. So what's going on is it's getting closer and closer and closer to 16. So that is my answer for this problem. Okay. So as basically you could say, as n gets really big, you add up all the terms, you get really, really close to 16, and you actually, you get there technically because when you round, if I went up to n is equal to 10 billion, okay, the calculator would not even show that. It would just show that it's equal to 16. Okay, that's pretty mellow. Okay, let's try another one here. Again, same directions. Okay, it's find the sum. So we got -15, 3, -3/5, and 3 over 25. So once again, you test it out. It's not a bad idea to test it out over a couple of terms. So it's -1/5, 3/5, -3/5 divided by 3 also gives you -1/5. Just a good idea to test it out. So that's r. Okay, and then a sub 1 is -15. So again, that's within range between -1 and 1. Use our equation, S sub infinity equals a sub 1, -15 over 1 minus a -1/5. So again, be careful. Put parentheses around it, and use your calculator, hit your fraction button, and your answer comes up to -25/2. Okay? That's the answer to that one. Pretty easy, right? Not bad. Okay? Okay, let's keep going here. Again, find the sum. And it's going to be 1/9, 1/3, 1 and 3. So if I divide 1/3 divided by 1/9, or 1 divided by 1/3, or 3 divided by 1, I get r is equal to, let's do 3 over 1. R is 3. Now here's the deal. It's 3. R is supposed to be between -1 and 1. Okay? So this shouldn't work. Okay? But here's the deal. If you forget about it and you try to plug it in, of course you can plug it in. R is 3. A sub 1 is 1/9. So I would have S sub infinity is equal to 1/9 divided by 3. Or 1 minus 3, right? Okay, and if I do that, I wind up getting -1 over 18. Now again, you guys are smart kids. You should look at this and go, oh, wait a second, that's impossible. Well, of course it's impossible. First of all, it's negative, and there's no negative here. They're all positive. So that's why it doesn't even work. Okay, you can plug anything you want in there, okay, but it's not going to give you the right answer if R is not between -1 and 1. So anyway, that's the deal with that. You basically, we're going to learn a nice little friendly word here now. If R is not between -1 and 1. So we're going to say absolute value of r is greater than or equal to 1, which basically means r is less than or equal to -1, or r is greater than or equal to +1. That's what this means, okay? So if that's the case, we say the series, and this is a good word, diverges. Okay? Diverges. And so basically diverges, kind of in like loose English terms, is it basically does not approach a specific number. What do you mean by that? It's going to go to infinity, or it's going to go to -infinity, or here's another example. If it goes from 5, -5, 5, -5, 5, if that was a sequence, it's not approaching any number. It's going back and forth and back and forth. That is diverges. Okay, diverge just doesn't go anywhere. Okay? All right, and then the other word that I'd like to mention here is converge. We'll see that one a lot. Converges basically does go to a number. So basically, it's not infinity, not a negative infinity, and not fluctuating. It's going to a number. It's going to 5. It's going to 0. It's going to -18,000, whatever. 1/2, doesn't matter. But it goes to a specific number. Okay, we say a finite number, as opposed to infinity, which is an infinite or infinite number. Okay, and this is when absolute value of r is less than 1, which means r is between -1 and 1. Not equal to, okay, it's really important, not equal to. Okay, because it's equal to, think of again, the series is going to stay at, if it's equal to, it's going to not go down in value, right? It's going to stay at 3, 3, 3, 3, 3, 3, 3, all right? So that's why you can't use the infinite geometric series formula, because it's not going to go to a certain number. Okay, it's just going to get bigger and bigger and bigger when I keep adding those terms. It's going to diverge. Okay, so converge and diverge, very, very important. All right, so let's use some notation that we already used before. Okay, and it's basically sigma notation. Okay, remember that sigma notation? And when sigma is related to sigpa, or as you like to say, carrot person, because cigarettes are bad for you, and don't be sexist by saying ma, so we say person. Never mind. Don't write that down. Okay. So n goes from 3 to infinity of 2/3 to the n power. So here's the deal. This value right here, what is that? That's r. Remember that? We kind of talked about this already. So r is the number that's actually being raised to the power. So that's pretty sweet. So here's the deal. We know r is 2/3, and how do you figure out a sub 1? Remember, a sub 1 is when n, this is the starting value here. When n is equal to 3, that's our first term. So I plug that in, 2/3 to the third power. So that gives me 8/27. That's a sub 1. Okay? And then we just plug it in. S sub infinity is equal to 8/27 divided by 1 minus 2/3. Again, using your calculator, you get 8/9, and that is the sum of that. Now, again, how do you recognize this is an infinite? Because remember, this is also an infinite geometric series. Well, you know that because, again, the word infinite right there. Okay, again, do not come up to me in the middle of a test and say, Mr. Griffiths, is this an infinite or just a regular one? I'll say, go sit down. Okay, go look at the top of this sigma sign, and you see an infinity. So that definitely makes it infinite. And then you know it's geometric because it's 2/3 to the n power. So that's geometric. And you know it's series because it's got the sum symbol, and that means you add all the terms together. Okay, so that's how you recognize it. Pretty easy. All right, so let's do another one here. If I said the sum n goes from 2 to infinity of 3 times negative 1/2 to the n power. Okay, so r, there we go, r is negative 1/2. In a sub 1, again, plug in that 2, so it's 3 times negative 1/2 squared, which gives us 3 times 1/4, or 3/4. Okay, so s sub infinity equals a sub 1, 3/4 over 1 minus negative 1/2. Put that in your calculator, hit the fraction button, and we get 1/2 as a final answer. Okay? Pretty easy. So let's just kind of do a quick summary here, math fans. So a little summary. Even though it's February and it's cold outside. Okay. If I gave you guys this, n goes from 2 to 10 of 4n plus 3. You guys should recognize this not as infinite anymore, because of course it goes to 10, but you should also see it's 4 times that. Remember, that's an arithmetic series. Okay, in this case here, d is equal to 4, because it's going up by 4 every time. Okay, if I gave you n goes from 2 to 10 of 2 times 3 to the n power, okay, you guys should recognize that as geometric series. In this case here, r is equal to 3. Okay, and then of course what we talked about today, n goes from 2 to infinity of 4 times negative 2/3 to the n power. Of course you recognize that as an infinite geometric series. Okay, again, r here is negative 2/3. Okay, pretty easy. So again, one more quick note here is, remember, if I want to find a sub 1, so to find a sub 1, so if I have, let me just draw the big sigma here, so n goes from, let's say, 3 to 10, okay, of, 2 times 3 to the n power. Alright, so if I want to find a sub 1, remember you basically plug in this value into there. That's your first term. So that would be 2 times 3 to the third power. So 3 to the third power is 27. So 2 times 27, which is 54. Okay, so just remember when you're finding a sub 1, don't plug 1 into here. Sometimes kids do that. You're plugging in the starting value. Okay, and to find if it's arithmetic, if it happens to be an arithmetic term or arithmetic sequence, and I have my summation, n goes from, well, we'll do that, 3 to 10. Remember, I need my a sub n. I need my last term, so make sure you plug in that to get your a sub n. This is your a sub 1, and this is to get your a sub n, your last term. And remember, the last thing is the number of terms is n, and that is basically, the number of terms is the top number minus the bottom number plus 1. So 7 plus 1 is 8. So there are 8 terms. If I asked you to find the sum of all those terms, that would be s sub 8. Oops, s sub 8. These are 8 terms. Okay? That's just kind of a little review at the end. But basically, that's it, math fans. That is an infinite geometric series, and hope you learned a little bit about that. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.